Hello guys, in today's video I want to talk about something I really love, that it is the general relativity theory from Albert Einstein. And I'm going to talk about something that really sounds impossible at first, but is actually real science, the real world, how we feel things. And what about to say you sounds a little bit strange at first, but time is not the same for everyone. What if I told you that time doesn't pass at the same speed for all people? That for some people, for some reason, time goes a little slower, and for others, a little faster. But why? Believe me, this is not science fiction. This is real physics, explained by Albert Einstein. So, we grow up believing that time is something absolute, immutable. 1 minute is 1 minute for everyone, everywhere. And this is really reasonable to think because we feel the time like, oh, and now it's 10 o'clock. In an hour, it is going to be 11 o'clock. I feel that an hour pass, and this is just my routine. I know that time doesn't change. In an hour isn't going to be 13, 1 p.m. It is going to be 11 a.m., you know. So we grow up that this is something that can change. But Einstein show us that this is not true. And the way he thinks it is really incredible because no one ever had contested the time, how the time passed. But Einstein have the creativity to think in something so much incredible. And maybe you might think, no, this can't be true. Time is absolute. Time is immutable. However, that's not the case. And let me show you guys why. Time, not only the time, but the speed of light and everything is affected by gravity. The stronger the gravity, the slower the time pass. That means, yes, this example really happens, but that means a clock closer to the beach, to the Earth's surface, runs is likely slower than a clock in the top of the Mount Everest. And it is really incredible that the time pass different from a people that it is on the beach from the people that it is on the top of the Mount Everest. And one of the confirmations of this idea came in 19 and 19 really fun here, during a total solar eclipse observed in Sobral, Brazil, yes, and also in Africa. Astronomers and photographers they photographed stars near the sun and proved that the sun's gravity bends light with the stars. Like there's a difference where the place that the stars should be with the difference that they works because of the curved space. And this was confirmed, and this was exactly what the Einstein predicted in his theory. So they want me more proof that isn't a quotidian proof. That so I'm going to say you another famous experiment that I really uh, an example more near from our reality, that it is the Heffel Keating experiment. I don't know if I am spelling it right. So scientists placed cesium atomic clocks. So it is some clocks really precise, you know. They put those clocks on commercial airplanes that flew all over the world. And when those clocks were compared to clocks that stayed on the ground, a difference was observed. The clocks that move faster and experience different gravitational fields measure time differently than the clocks that was in the plane. So there is a difference between the clock that stay on the surface than the clock that flew on the plane. So that it is a proof that the time passed wrong and the clock wasn't wrong. The time really passed different from then, you know. And this is uh, uh two factors that affected this to happen. The gravity, as I already said, and also the the speed of the that the clock travel, because this also affected on how the time pass. There is one example, another that it is a fictional example that isn't a real experiment that really happened, but something like a theory, something just made up from our mind, just for we understand that it is the example from the Gemini. I don't know if it is by this way that we say that it is if one Gemini. I don't know if Gemini say that by this way, and I aren't going to research anyway. If one of them stay in the Earth and the other flew away in the Earth in a space on around the world in the speed of light, the one that stay traveling when we returns in the Earth like 10 years after, he is going to be younger than the one that stay in the Earth because the time passed different for them. And this is something really incredible. Like how something that it seems absolute for us, it is just different. So, this is important to understand. In everyday life, this is different. Are extremely small, we don't feel it. Our speeds are low, and the Earth's gravity isn't strong enough for us to feel them. But physics can prove it, can measure the effects, and the modern technology actually depends on them. So the big deal is time is not absolute. Time is flexible. Time depends on movements and gravity. In a way, everyone really does experience time is different. So, Einstein didn't just change physics, he changed how we understand reality itself. Time feels simple, something that it seems absolute but is not. So, thanks guys for watching this video, a little different topic that I don't know if it seems clear. There is a little of improvisation in the middle of it that I wanted to bring another example. So thanks you for watching. See you next time. Bye bye.